Boyle's Law. Okay, here's what we're going to do. We're going to start boiling things. No, I'm just kidding. It's not Boyle's Law like that. B-O-Y-L-E-S. Named after Robert Boyle, B-O-Y-L-E, a 1600 century, actually I think it's what, like 17th century, which is the 1600s. English scientist who performed experiments on the spring of air and in an enclosed tube. So, from his experiments, he was able to derive this gas law that bears his name. At constant temperature, the volume of a gas is inversely proportional to the pressure that you experience. So you have P1V1 equals P2V2. All right. The way we're going to test that is with this pipette. It's got a long tubey thing at the end. And we're going to use some food coloring and water. And we're also going to use a few books. So you need to go out and go grab 6 books that are about relatively exactly the same size. And I happen to grab a whole bunch of Disney books, or this is my favorite, one of my kids' favorite one. It's Nino, Wrestlers of the World, Clifford the Big Red Dog. It doesn't really matter what books you grab, just about the same size. You don't want too heavy books for this experiment. I'll explain to you why. And I apologize, but I can't find my food coloring anywhere. So what I'm going to use instead is I'm going to use soy sauce. Now, what you don't want to do is you don't ever want to take your pipette or whatever you're doing your experiment with and dip it directly into some kind of food source like that. Because you don't know what the last experiment you did with this thing is. And even if you cleaned it, it might not be good for consumption. So what I always do is I always take something like this and I'll pour it into here. I don't need a whole lot, but I'll get about that much. And whatever you do, if you don't use all of this, do not pour this back into your container of soy sauce, because I'm going to use that soy sauce later on for cooking, and I don't want to contaminate it. I don't know what the last chemical that was in here is. So I try to keep my food and my chemistry stuff separate, but in this case, I just poured that up over there, and I made sure that the lip of that container didn't touch that thing. It just kind of poured straight into there, and so everything should be nice and clean and sterile. Now, what I'm going to want to do is I want to fill up this thing with your liquid. It could be colored water. It could be soy sauce. I chose soy sauce because it's going to be really easy to see for you guys. And what I'm going to do is I'm going to fill up the bulb with this thing, and then I want to fill up maybe a few millimeters of water in the stem. This is the stem. But I definitely will need an air column of some sort. So let me show you the technique that I figured out. What you're going to want to do is squeeze all the air out as you can, and then just use it and suck up as much of that liquid as you can. There you go. Now you're going to have a little bit of a bubble right there. And so turn this upside down like this and squeeze out again. You're going to see the thing in the bottom, or the thing bubble, and then you're going to see the liquid kind of go all the way. So there's all liquid in here. And then I'm going to suck up the rest of this liquid. There we go. Now, if I were to take this out, I told you you'll want the stem to have a few millimeters of water, but not all the way like that. So I would drop in, and I'm going to bend it one more time. I would drop in, maybe give it 3 drops. 1, 2, and 3. That didn't get as much as I wanted. I'm going to go give another couple drops. Let's go with 2 more drops. 1 and 2. It's about there. I think I want to go maybe 1 more. Boom, done. This is perfect. This is exactly what I want. So the bulb is full. This thing is full. We're good. Then I'm going to take the clampy thing. I should be more scientific. It's called the clamp. I'm going to take the spring clamp and I'm going to clamp the edge of this thing right here. Press it down, because what I want is make sure no gas escapes. Okay, all right, we're good. So what I'm going to use is I'm going to use a ruler. I wonder if the ruler they provide is a little bit better. No, it's about the same. All right. I'm going to measure in millimeters exactly how many millimeters that first line is. So from the tip of the spring clamp all the way down here, to me that looks like a good 8. Now there's a little bubble of air in there, and I'm not going to try to worry about that too much. But yeah, that looks like exactly 8 centimeters. So now what I'm going to do is I'm going to take this, put it like this, and then I'm going to put a book on top. Oh, I need to write down that information, so I wrote down 8. I'm going to put a book on top. There we go. And then I'm going to measure it again. And then I'll put another book on top. And I'll measure it again. I'll put another book on top. And then I'm going to measure it again. When I say measure it again, I mean measure the distance between the line. You can't really see it. There we go. You can kind of see it. The line and the spring clamp. As this thing pushes on it, it's going to keep moving. Now, to be honest with you, I think I happen to choose very, very light books. So you might want to go with, I'd say a Dr. Seuss book is probably a good, nice weight for it. But you really got to just play with it and see. All right, so now you can kind of see this thing moving. Actually, you can't see it. Let me see if I can angle that. There we go. Okay. There we go. Can you see that? Okay. Let's try a heavier book. Yeah, these books are really light, so I don't think it's going to really give you too much of a good measurement. You might want to go with some heavier books, a little bit heavier than this. What you don't want to do is go too heavy. I think the lab says that you don't want to pile this thing more than 10 centimeters high. That's a lot. 100 millimeters is a lot, yeah. You don't want to pile this thing more than 10 centimeters high. So I guess a good Dr. Seuss book, 6 of those would be good. The reason being is because if you squeeze this thing too much, it's not going to pop as much as the material that it's made out of is a very low density polyurethane. And what will happen is this thing will probably end up stretching more than anything. And if that stretches, what that's going to do is it's going to really corrupt your data. So from this, you're actually going to take these measurements and then make a little graph out of it. And yeah, that's how you're going to do this experiment. So to maybe amend what I did in my video is I used my books were a little bit too light. I would go with something a little bit heavier, but not too heavy. And you want to get them to be all books of the same size. It doesn't really matter which books you choose, just as long as you choose books that are of the same weight and size, and that way you can see, a gradual increase.